Hello guys, how you doing? Hope all is going well. I just wanted to right now go over for the workbook 3.1 and just kind of go over the highlights of this whole section on scatter plots, correlation. Remember the whole chapter is on bivariate data. And remember bivariate data right here, it says right here, we'll learn the approach to data analysis that we learned for a single quantitative variable can also be applied to explore the relationship between two quantitative variables. So far we just showed the relationship between one quantitative variable and like histograms or dot plots. But now, right now, we're going to go and figure out the relationship between two quantitative variables. We'll learn how to describe the overall patterns and departures from the patterns we see. Finally, we'll learn how to create a mathematical model to describe the overall pattern. This section will focus primarily on displaying the relationship between two quantitative variables, describing its form, direction, strength, and unusual features as well. Like the previous chapters, you'll find that technology can be used to do the most difficult calculations. However, be sure to understand how the calculator is determining its results and what those results mean. All right, so for an explanatory variable, all right, that's presented normally on the X, or you could say horizontal axis. An explanatory variable may help to predict or express changes in the response variable. So they gave an example in the book about like the length of your hand span and the number of candies that you would grab out of a jar. And they're trying to see if it matters like how wide your hand span is and how many candies you can grab from a jar. So right here, the explanatory variable may help to predict or explain changes in the response variable. And like probably when you first learned this, you called this the independent variable. In this class, independent means something different, but that's that's kind of what the classic version of an explanatory variable is. It's like your independent variable. Response variable, that measures the outcome of the study. So right here for our example right here, if right here the explanatory would be like your length, the explanatory variable is the length of your hand span, maybe in inches or something like that. And the response variable right here measures the outcome. So the outcome would be right here for our example, the response variable will be the number of candies grabbed. Okay. Now, make sure right here we're talking about variables, right? So make sure when you write down what the variable is, it's supposed to actually be something that can vary. So be sure that there was an AP exam tip on page 153. Right here, like if something, for example, for your explanatory variable, if you're doing, you wouldn't just say right here, hand span. You would say the length of your hand span, because that can vary. It could be small, it could be large, whatever. And make sure you put number of candies grabbed. Don't just put candy, okay? Put number of candies grabbed, all right? That shows you it's a variable right here, okay? And this is on page 153 for the AP exam tips. So make sure that when you're putting a variable, you're writing what the variable is, that this can actually vary. Okay. Scatter plot shows the relationship between two quantitative variables measured on the same individuals. So a scatter plot shows the relationship between, this is all in your slides, by the way, if you have to go and look any of these up, it's on the slides on Google Classroom. Shows the relationship between two quantitative variables measured on the same individuals. Each individual represents a point on the graph. Okay. Direction, form, strength, unusual features. There's a whole slide on this if you need to look this up in more detail. Direction, remember, can be positive. Right here, it also can be negative or no association. Form, that would be either linear or it could be nonlinear. Strength, we'll say weak, moderate, or strong association. Unusual features, you just mentioned the outliers and or the distinct clusters. We did an example of that today. Positive association, negative association, or no association. Positive association. Okay, that means above average values of one variable accompany above average values to another variable. Negative association. Above average values accompany below average values of the other variable. All right, so above average values of one variable accompany below average values of another variable. Okay, you think about that negative association, it's going down right here. So right here is your X value is above average values, your Y value is below average values. It's going downwards from left to right. No association means knowing the value of one variable does not help predict knowing the values of the other. Okay, if you need more help with this, again, this is on your slides. You can check that on Google Classroom. Lastly, correlation. R. All right. R measures the direction and the strength of a linear association. Now, it must be R is only for linear. If it's a nonlinear relationship, then there is no R. Okay, so it measures the direction and strength of a linear association. And there's more detail of this on the slides. He gave you examples of that it can be rendered from -1 to +1. -1 and +1 are perfect relationships, remember. And 0, there is no association at all. Okay, you can check your slides for that. Okay, so this is just from the classwork right here. Just want to put that there because I am going to go and I do want you to go and fill out these with this workbook right here. So there it is. All right, I hope this helped. I'll keep it up there for another minute if in case you have to get to pause this or anything like that. There is everything all in one. Okay, have a good day. See ya.